Select questions from the final review. Discuss the statement and tell what possible misuse or misinterpretation may exist. In a study of patients with flu symptoms, each patient was found to have improved symptoms after taking apple cider vinegar. Therefore, apple cider vinegar cures the flu. Let's discuss the statement and tell what possible misuse or misinterpretations may exist. So let's read through our options. The statement is valid because the patients may have improved on their own without taking apple cider vinegar and have improved symptoms translate to patients being cured of the flu. The statement is valid because each patient has improved symptoms, which translates to patients being cured of the flu. The statement is not valid because the patients may have improved on their own without taking apple cider vinegar, and having improved symptoms does not necessarily translate to patients being cured of the flu. The statement is not valid because having improved symptoms does not necessarily translate to the patients being cured of the flu. So, what this statement is saying is that patients had the flu, they took apple cider vinegar, and that they got better. That has nothing to do with apple cider vinegar. Like, I could say, I drink apple juice every day, and that prevented cancer, right? I could say that, whether it's true or not. That's an invalid statement. So we know that these are going to be invalid. So it's not valid, not valid. So we know it's not A or B. So let's read through C and D. The statement is not valid because the patient may have improved on their own. Right there, that tells you that that is the answer, because they could have improved on their own. Who knows what they did? Maybe they drink a bunch of water. Maybe they got rest. Maybe they are just have a better immune system. We don't know what these people did to get better because they didn't study that. They just said, here's apple cider vinegar, hope you get better. And they did get better. But there's a lot of outside factors that can contribute to that. And it's not D, so it is C. It's not D because having improved symptoms does not necessarily translate to patients being cured of the flu. While that is true, we want to know really why it's not true. And the reason why it's not true because improved symptoms doesn't always translate to patients being cured of something. The thing here is correlation does not mean causation. All right, number 3. The following table shows the results of a coffee taste a coffee taste test given at a local grocer. So if one of the individuals is selected at random, find the probability that they prefer brand A. So we want to know everyone that prefers brand A. So we're going to look at all of brand A. So all of brand A is 852 people out of a total, so total they asked 2,392 people. So the probability of brand A is 852 out of 2,392. Now it says to round, so since it's rounding, we're actually going to plug this into our calculator. And when we plug this into our calculator, we get 0.356187,291. It says to round to 4 decimal places, so 1, 2, 3, 4. If we look next to it, it's an 8, so we're going to round up to 0.3562. Our part B, the probability that they prefer brand A given that a man is selected. So we're looking for now specifically brand A given that it's a dude. So what we're really looking for is the probability of A given that it's a man. So what we're going to do is look at just the men portion of brand A. So the men portion of brand A is 512. Out of total men, the total men, because that's what it's asking, what's the total out of the men, is 1429. It says to round again, so we're going to plug this into our calculator and get 0.3582925,122. Round to 4 decimal places, so 1, 2, 3, 4. We look over, it's a 9, so since it's a 9, we're going to round up to 0.3583. List all the subsets of the given set, goat and sheep. So the first thing we're going to do is remember that when we list subsets, there's always an empty set. When you list subsets, there's always going to be an empty set. So we want to look right now the one that has an empty set. That does not. That does not. That is not empty. So that's not an empty set. These aren't even sets. That's not an empty set. So now it's between A and F just based off of knowing subsets have empty sets. Something more about subsets. Subsets, it's in the name, they are sets. They're sets, so that means when we group them together, everything has to be a set. So if we look at F, F is not a set. Goat, sheep right here, that's not a set. But if I look at A, we have empty set, goat, goat, sheep. Remember, when we do subsets, we put them all together. So based off of just knowing what a subset is, we know it's A. Determine the slope of the line through the given points. If the slope is undefined, so state. So we need to find the slope. There's the formula for that. Our y2 and y1, they actually come from the points. So this is x1, y1, and this is x2, y2. So let's plug it in. We have y2, which is represented by 12, y1, which is represented by 2, over x1, x2, which is represented by 6, minus x1, which is represented by 4, and from here we simplify. So 12 minus 2 is 10, 6 minus 4 is 2, and then 10 divided by 2, we get 5. So our slope is 5. Remember, 0 over a number is 0 slope. Number over 0 is undefined slope. Use your calculator. The top will give you 0, the bottom will say error. That's how you know it's undefined. To use an automated teller machine at a certain bank, that's what ATM means, by the way, you must enter a 4-digit code using the digits 0 through 9. That's true, we know that. How many 4-digit codes are possible if repetition of digits is permitted? So repetition of digits is permitted. That means we can use the same digits. It can be 1, 1, 1, 1. It could be 1, 1, 2, 2. It could be anything we want. So we're picking 4 numbers. 0 through 9, that's 10 digits. So if we have 10 digits to pick from, I can pick any 10 for my first one. And since we're repeating, I can pick another full 10, another full 10, and another full 10. Because I can be any 10 digits and I can repeat them. So 10 times 10 times 10 times 10, we get 10,000 different codes. That's not a lot if you think about it. With repetition being allowed, there's only 10,000 different type of pin codes. It's not a lot, so you have to imagine some people out there in the world share your pin code. That's weird, right? Alright, number 10. We're going to use the Venn diagram to determine whether the sets are equal for all sets A and B. So we have A intersection complement B, and complement A intersection complement B, and the complement of all that. So we're always going to break it down into its pieces. So our first piece, we have A, then we have the complement of B, and now we want to know where they meet. So A is everything in circle A. Everything in circle A is 1 and 2. Complement B is everything not in B. So every number that's not in circle B is 1 and 4. Now, where they intersect, what they have in common is just 1. Now let's do our second piece. So we have complement A, complement B, the the intersection of those, and then we need to find the complement of that. If you break it down piece by piece, it's not so daunting. So let's find what's not in A. So every number not in the circle A is 3 and 4. Everything that's not in circle B, well, hey, we already have that answer, is 1 and 4. Now we need to put them together. So if we put them together, the only thing they have in common is 4. Now I want every other number in this box that has nothing to do with A, B, or AB. So no number that has to do with 4 is 1, 3, 1, 2, I forgot the 2, and 3. So now we're going to look at both of these and let's see if they're equal. They are not equal. This is 1, that's 1, 2, 3. These need to be identical for them to be equal sets. So no, these statements are not equal. Use the Venn diagram to determine the roster form of the indicated set, A union B, and the complement of that. So what we're doing is breaking it down into pieces again. We want to first know what is the union of AB, and then what's not in AB. So the union of AB, I'm going to highlight everything of that because it's union. That means we want to combine everything in A with everything in B. So let's highlight everything in A. So this is circle A, and this is circle B. And we're unioning it. We're putting it all together. So we're going to put all of those numbers together. All of those numbers together are 1 through 9. So that's when we put them together. Now, what's missing from the set? What's missing from the universal set? That's what the complement is. So everything that we did not highlight, that's what the complement is, which is 11 and 10. So our set is 10 and 11. Graph the equation and state the slope of the line if the slope exists. So we have x equals 4. So technically this is saying x is 4. So if that's x is 4, we're going to go to where x is 4. X is 4 is right there. Now we draw a line that goes through that axis. So this is a vertical line. Vertical lines have an undefined slope. How do I remember that? You cannot climb up a building. You can't. That's impossible. You're not Spider-Man. You can't climb up a building. If it was a flat line, now this has nothing to do with it. If it were a flat line, that's a 0 slope because it's a flat line. You can walk that. It's a flat surface. But when you go straight up and down, that's not a flat surface. You cannot walk a flat surface like that. You can't walk up a building. That's how I treat it. Find the number of distinguishable arguments of the letter of the word undecillion. Alright, so this is where when we have matching numbers or matching letters, we have to take out those letters. So total, we have 11 letters. There's 11 letters here. Now let's see which ones repeat. So we have 2 N's. And then we have, let's see, we have 2 I's. And then we have 2 L's. That's all the repeating numbers. So this formula is always your total, the factorial of that, and then your numbers that repeat. And it can go forever. We only have 3 repeating numbers though. So our total is 11, so 11 factorial over our repeating factorials. So we have 2 factorial, another 2 factorial, and another 2 factorial. Alright, so 11 factorial, remember that's 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2, and that comes out to 39,916,800. 2 factorial, 2 factorial, 2 factorial. 2 is a special factorial. It's just 2 times 2 times 2 because that's 2 times 1, 2 times 1, 2 times 1. So it's just 2 times 2 times 2 and we get 8. So we have 39,916,800 over 8. And when you plug that into your calculator, we get 4,989,600. So there's just under 5 million ways you can change all of these numbers or all these letters together and create random stuff. A music store in New York City. At a music store in New York City, 58 people entering the store were selected at random and were asked to choose their favorite type of music. Of the 58, 18 chose rock, 16 chose country, 2 chose classical, and 22 chose something other than rock, country, or classical. Determine the empirical probability that the person entering the store favors rock. So we want to know the probability of someone liking rock music. So it's always how many like it over the total. So total, we have 58 people. And that's over how many people actually liked rock. It was 18. Now, it says to simplify your answer. No decimals. It doesn't say to round. It says simplify. So that means we have to simplify using fractions. These are both even numbers, so we can divide by 2. And when we do, we get 9 over 29. Now, 29 is prime. That's how I know I cannot simplify anymore. So 9 over 29 prefer rock. So that means about 9 out of 29 people, they're going to like rock music. About. Alright, let's determine the empirical probability that the next person entering the store likes country music. So it's always how many actually liked it over the total of how many people they asked. So 16 people liked it out of 58 people they asked. Now these are both even numbers, so since they're even, we can divide by 2. And when we do, we get 8 over 29. Now 29 is prime, so we know we can't do any more. So 8 out of 29. Now let's determine the empirical probability that the next person entering the store favors something other than rock, country, or classical music. So we want to know the probability of other. So other, that was 22 people chose something other than those 3 styles. So that's 22 out of the total people, 58. Those are both even numbers. Since 22 and 58 are even, we can divide by 2. And when we do, we get 11 over 29. Now 11 and 29 are prime, so we cannot simplify anymore. So 11 out of 29. A refrigerator contains 4 cans of diet soda and 9 cans of regular soda. If 3 cans of soda are randomly selected without replacement, determine the probability that all cans selected are diet. So without replacement, that means once we take a soda out, it does not go back in the fridge. It's always good to figure out the total of cans you have. So we have 4 diet and 9 regular. So that means we have a total of 13 cans in our fridge. So we have 13 sodas in our fridge. So we're picking 3. We're picking 3 cans. So if I want to pick all diets, I have 4 cans of diet. So that means I have 4 cans, and then I pick one. That means there's only 3 left. Then there's only 2 left. And that's out of our total. So we first start with 13 cans of soda, then we take one out, we only have 12 cans of soda left, and then we only have 11 cans of soda left. And we're going to multiply. So 4 times 3 times 2, we get 24. 13 times 12 times 11, we get 1716. Now, both of these numbers are even. You can keep dividing by 2, or you can just figure out how many times you have to do that. And they actually have 12 in common. So you can divide by 2 6 times. So you can divide by 2, divide by 2, divide by 2, divide by 2, all 6 times. So we can divide by 12. And when we do, we get 2 out of 143. It also says to use a simplified fraction, so that's how I knew to not use a decimal and use a fraction. A board game uses the deck of 20 cards shown to the right. 2 cards are selected at random from this deck. Calculate the probability that both cards selected have a bird, both with and without replacement. So we want to know if we pick 2 cards with replacement, what's the probability of having 2 birds as your card? So we're picking 2 cards. There's a total of 20 cards. And with replacement, that means we pick a card and we put it back. So both picks are going to have 20 cards. Now, how many bird cards do we have? We have 5 bird cards. It's the first row. So we pick a card, we put it back. That means we still have 5 more. So we can simplify these fractions to work with smaller numbers, or you can just multiply straight away. It does not matter. I'm going to simplify because 5 over 20 is 1/4 times 1/4, and we get 1 over 16. Alright, now we want to know, without replacement, what is this going to look like? So we're still picking 2 cards. And we have 5 to begin with. We pick one, we do not put it back. So that means now we only have 4 cards of birds. That came originally from 20 cards, but we took a card out. We took one of those bird cards out. Now there's only 19 bird cards left. So 5 times 20, you could also simplify right away. It does not matter. So or 5 times 4. So you can simplify to 1/4. It does not matter. I'm just going to multiply straight across. We get 20 over 380. Do you notice they both share a 0? That actually cancels, by the way. So we have 2 over 38. Those are both even. Since they're both even, we can divide by 2. And we get 1 over 19. A multiple choice test question has 8 possible choices. If you randomly select one of the choices, what is the probability that you select the correct answer? So we want to know the probability of correct. Well, on a test, there's only one correct answer out of how many total choices you have? 8. It says to use a fraction, so we're going to use a fraction, 1 over 8. If you selected one of the choices, what is the probability that you selected an incorrect choice? So that's just the literal opposite of correct. So we want to know the probability of incorrect. So only one is correct. Only one answer is correct. That means the rest of them are not. So 7 out of 8 of them are not correct answers. If you can eliminate 4 of the 8 choices and randomly select one of the remaining choices, what is the probability that you select the correct answer? So now we're saying, I know out of 8 of them, 4 of them are for sure not the answer. You can eliminate 4 of them right now. So that means you only have 4 left over. If you only have 4 left over, still one of them is correct, so you have 1 out of 4 chance. If you can eliminate 4 of the choices and randomly select one of the choices, what is the probability that you have an incorrect answer? So that's just the literal opposite of part C. So we eliminate 4 answers, that means we have 4 left, and 3 of them are wrong. Determine whether the argument to the right is valid or invalid. You may compare the argument to the standard form or use the truth table. That does not have anything to do with a standard form, so we need to come up with a truth table. So whenever we have an argument like this, in between is always an and the therefore is always an if-then. So when we piece everything together, we're going to have P if and only if Q and Q or R, if then P and R. Alright, the therefore part, that's going to be by itself. So we're going to group the top part together, and then the bottom part is just the bottom part. There's nothing to group it to. Alright, let's number our columns. So we're going to do this one first. Remember, you always use parentheses and brackets first. So opposite sides of the connector, then we bring it together. So 1 and 2 give us 3. That's the parentheses and brackets. Then we move outside of that. That's number 4. And then we need to get our solution, which is the last column, and that's column 5. To get column 5, we're going to bring 3 and 4 together to give us 5. Alright, let's use it. So we have P if and only if Q. That means we need doubles. We can only have pairs to make it true. So we're looking at P and Q. So looking at P and Q, we have true, true. That's true. Again, true, true. That's true. True, false. That's false. True, false. That's false. False, true. That's false. False, true. That's false. False, false. That's true. False, false, that's true. Remember, you need doubles. If you have double arrow, you need a pair to make it true. Alright, now we're looking at Q or R. For OR, only one thing needs to be true for OR. So we have true, true, that's true. You only need one thing that's true. True, false, that's still true. False, true, that still has one thing that's true, so it's true. False, false, that's the only scenario that something is false for OR. True, true, that's true. TF, that's T. FT, that's T. FF, that's false. Now we're going to bring them together, looking at our opposite columns with an AND. So AND, both need to be true. It has to be TT. That is the only case where you have a true statement. So TT, that's true. That's true. Oh, false. Stop there. That's false. Again, false. That's false. False. That's false. False. That's false. We have true, true. That's true. True, false. That's false. Alright, let's do our fourth column. P or R. P and R. So we're looking at P and R, and since it's and, we need double T. That is the only scenario where you get a true statement. So true, true, that's true. True, false, that's false. True, true, that's true. True, false, that's false. You need double T, so you need true, true. The rest of them in the P column are false, so I know the rest of these are going to be false. Alright, now we bring it together with an if-then statement. So the only rule for if-then statement is TF is false. Everything else in if-then is true. So the two columns we're going to be looking at are this one and this one. So we have true, true, that's true. TF, that's false. FT, that's true. The only scenario that creates false is TF. So this is false, false, false. That means they're all going to be true. We have TF, that's false. This is false, so it's going to be true. So now what we do is we look at our answer column. It needs to be all T. It needs to be all true. Since it's not all true, we have two falses there. This is invalid. Write this statement in symbolic form, then construct a truth table. So if today is Monday, then the aquarium is open, and we can look at the turtle exhibit. Alright, so it told us P is going to be today is Monday, Q is going to be the aquarium is open, and R is we look at the turtle exhibit. So our P is today is Monday, so today is Monday, that represents P. We have if then, and there's a comma. Since there's a comma, parentheses. Q is the aquarium is open, so the aquarium is open. And R, we can look at the turtle. So our first column is going to be the parentheses, because that's how my MATLAB sets it up. The second column is going to be the entire thing together. Alright, so for our first column, we're going to determine Q and R. So we're going to be looking at Q and R to figure out our first column. So it's and, that means we need double T. So TT, that's T. TF, that's F. TT, that's T. TF, that's F. The rest of these are false, so I know that these are going to be false. Now we're going to bring it together. So bringing it together, we're going to be looking at P and this statement right here. So we're going to be looking at our P column and this column right here. And it's going to be P first, then that column. So we're bringing it together with if-then. So if-then, the only scenario is TF, that's false. Everything else is true. So we have TT, that's true. TF, that's false. TT, that's true. TF, that's false. FF, that's true. FF, that's true. FF, that's true again. And FF, guess what, that's true again. The bottom parts are literally just the numbers that we filled out. Because I upload this as a PDF, so it creates all the weird stuff that my MATLAB does behind the scenes. But that's what all these numbers are. So if we look at column 13, it would be F. Or sorry, yeah, F. So that's all it is. A box contains 3 cards. One card is selected. One card A box contains 3 cards. On one card there is a sun, S. On another card there is a pair, P. And on the third card there is a triangle, T. 2 cards are selected at random with replacement. That means we put it back. Let's complete parts A through E. So we're going to determine the sample points in the sample space. So the formula for that is just how many times you're picking. So we have 1 pick and 2 picks because we're picking 2 cards. We're picking 2 cards and with replacement. So we have 3 cards to pick from. We put one of the cards back. We have another 3 cards to pick from. So 3 times 3, we have 9 total. So our sample space is 9. That means when we branch it out, there should be 9 groups. So if we want to look at all of our sample spaces, this is a sample space of 3. So it's not A. This is a sample space of 1, 2, 3, 4, 5, 6. That's not it. This is a sample space of 1, 2, 3, 4, 5, 6. That's not it. So if we look at our sample space here, that's 9. So it is C. Also, if we pick an S, we can get an S, P, or T. If we pick a P, we can get S, P, or T. If we pick a T, we can get S, T, P, or T, because it's with replacement. So this is our sample space. That means we have SS, SP, ST. We have PS, PP, PT. Then we have TS, TP, TT. And you notice there's 9 in our sample space, so we look for the option that matches, and it's B. Alright, let's determine the probability that 2 pairs are selected. So we're going to simplify your answer. That means do not use a calculator. So total, there's 9. There's a total of 9 in our sample space. Now, which one of them just has 2 pairs? Only one of them. So 1 out of 9. Let's determine the probability that the card contains a sun, and then a card containing a triangle. So we want sun, then triangle. So if we look for ST, there's only one ST, so that's 1 out of 9 of them. Alright, let's determine the probability that exactly one card containing a pair is selected. So we want to look for everything that has a pair. So this has a pair. 1, 2, 3, 4, 5. So we want to determine the probability that exactly one pair. So we only want to see one P, only one pair. So here's one, there's one, there's one, there's one. That's 4 out of 9 of them.